Yeah, grab one of the little sheets of paper that are on the back table back there. Okay. First things first. The first thing that we need to do is we need to add the other 3 safety guidelines. So let's do that real quick. So turn to the page in your spiral notebook where we put glassware safety, fire safety, electrical safety. And let's go ahead and add sharp object safety. Cut away from yourself. Notify the teacher immediately of any injury. I thought you were going to work down there. Oh, okay. Grab one of those from that back table right there. And then that's what we're doing right now is spiral notebook. We're adding the last 3 safety guidelines to what we started yesterday. So we don't do dissections in environmental science, but we use scissors. We do use sharp things. At this point in your life here on this earth, chances are you're okay with scissors. However, you can cut yourself if you're not paying attention. The idea is that if it's a beaker that has a chip or a break in it, if it's a pair of scissors, if you cut yourself, then I need to know. I do need to file an accident report, fill one out. And the thing is, especially if you're using, say, a pair of scissors that somebody cut something with that had goo on it or whatever, it's contaminated, and you cut yourself and you get that inside you, and we didn't wash it off and take the appropriate steps to take care of it, then I get a parent calling me saying, oh, my little Bobby Joe or little Sally Sue, their arm fell off because it got infected and blah, 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 blah. Now maybe all it is a stump and it's all your fault. So I want to avoid those kind of conversations, and so we need to make sure that we watch no matter what it is. I've never had any major cuts in this class. When I worked junior high, I had a student put their arm through the door, so it had a bigger pane of glass than that, and it didn't have the little crisscrosses in it that reinforce it. It was just a pane of glass. And the door swung back, and they put their hand out to keep it from swinging back, and it accidentally, their arm went through the glass. And that's the worst cut I've ever seen. And I never want to see that again in my life. It was pretty rough. So you let me know, no matter how bad it is, so that we can take steps to take care of it. All right, spill hazard. Simple and easy, let me know, and then I'll tell you, okay, go ahead and clean it up. If you bring drinks in, I don't care about that, but sometimes if they're cold drinks, they sweat on the table. I just ask that you get a paper towel, lay a paper towel down before you put your drink down, or make sure you wipe it up afterwards. So that way somebody that comes in after you, if they put their books down, they're not putting it in a sloppy mess. But please let me know, especially if we're doing a lab activity, because I need to know what was spilled where. And that way if somebody comes up to me and says, oh, I got this all over my sleeve, what do I need to do? Is it rinse it off? Do we need to do something worse than that? And then finally, heating safety. Hot glassware does not look hot. You are not going to be able to tell if it's hot or not. Treat everything like it is hot. I've got this Erlenmeyer flask. You're in here right after the biomed class, so it's entirely possible that they may have been heating the glassware, using it for something that had hot stuff in it. So it's not going to glow, it's not going to flash or anything like that. It's going to look exactly like this. So the best course of action is to treat everything like it's hot. If you're not sure if you need to move it for some reason, what you would need to do is you need to check to see if it's hot first. The back side of our hand is much more sensitive than the palm, so don't touch it with the back side of your hand because it's more sensitive than the palm. But get it close to it. If you hold it close to it, you'll feel the heat radiating off of it if it's hot. So if I don't feel anything, that doesn't mean I'm just going to grab hold of it. That means I'm still going to be careful about it. But I'm going to check first. And then if I feel heat coming off of it, I know I don't need to mess with it at all without some kind of protection. Remember those big, thick thermal gloves? But if it doesn't feel hot, then I'm going to double check, and then I can move it safely. It says, do not heat closed containers. So I've got a cork in this Erlenmeyer flask. So why would I not want to heat it? It looks really cute with this cork. If we're lucky and we heat that up, the cork will pop off and hit somebody. And that would just not be good either. But if we're not lucky, if it's sealed enough that it doesn't, then there could be enough pressure that builds up that it actually shatters the container itself. And now you have hot glass, sharp glass, hot, sharp glass, and hot chemical coming at you and the people around you. So we don't ever heat closed containers because it could build up the pressure in it. Remember, for glassware safety, we're going to double check. You're going to let me know if anything's chipped or broken. If something breaks, things are going to break. Are we going to pick it up with our hands? No. Broom and dustpan, and we are not putting it in the regular trash can. We have a special place to put broken glass. All right, we're good with that. So next, whoops, it would help if I grab one. It would. Next, we have a vocabulary sheet. Vocab sheet. So I want you to turn in your spiral notebook until you have 2 clean pages side by side. So go past all your safety stuff, 2 clean pages side by side. Okay, so we're going to take this vocab sheet, and I want you to fold it over so that we can see the terms, but we cannot see the definitions. So fold it over so that we can see the terms, but not the definitions. Then you're going to tape it in on the left-hand side. 1 little piece of tape on the edge, 1 little piece of tape on the fold. 2 little pieces of tape, tape it in on the left-hand side of your spiral notebook. Tape it in on the left-hand side of your spiral notebook. Two little pieces of tape, we'll tape it in real well. Okie doke. Now we're going to go through the definitions. When I draw your name, I'm going to ask you to read a definition out loud. Why? Because everyone loves to read out loud, right? Yes, Mrs. Johnson, please pick me. Why not? All right. Please read for us the definition of hypothesis. And sometimes there will be a definition where you don't know the term or you don't know the word or you never that's fine. If you pause, so like if you say a testable idea or if you pause, then I'll fill it in for you. Now I am asking you to repeat that word. I'll say explanation, then you say explanation, and keep going with it. So if you pause, that's telling me, hey, I need a little help with this word, and that's fine because we're all in the same boat. A lot of this stuff I trip over as well. It doesn't matter. That's what we're here doing it for. All right, hypothesis, definition of hypothesis. Elena Ray? Okay, I knew you were in Elena, but I can't remember which one. I'm getting better. All right. Stetson. All right, so that's the thing. We're taking a step up. You may have heard hypothesis as an educated guess. So we're going to take it just a step further. It has to be something that's testable, and it's actually an explanation of what you think is going to happen. All right, next, controlled variable. What does AKA mean? Does anybody know what AKA? Also known as. So it's also known as the constant. Controlled variable. Read the definition of controlled variable, please. Lexi R. And we want to keep as many factors the same in an experiment as possible. Because if everything's changing, we don't know what is the change that's causing an effect. So in an experiment, there's only going to be one thing that we purposely manipulate or change. Everything else we want to try to keep exactly the same. Next term, independent variable, also called the manipulated variable. Read for us the definition of independent variable, please. Aiden? And if I am purposely changing it, I am doing it because I want to do it, I am purposely changing that one thing. It's not an accident. So sometimes there's an experiment and variables change, but I'm not purposely changing them. We try to knock those out as much as possible. If I am purposely doing it, I am poking with it, I'm manipulating it, I'm making sure that I change that. Dependent variable, also called the responding variable. Definition of dependent variable, please. Elena? All right, so because I manipulated this, because I changed this, what's going to happen now? If I poke it, what's it going to do? If I add a chemical to it, what's it going to do? So my adding chemical is the independent variable. I'm purposely doing that. I'm poking it. That's the independent variable. That's what I'm purposely doing. So the response, the reaction, the results, that's our dependent variable. Most of the time, we're going to want our dependent variable to be measurable. We want to count something, or we want to see a color change, or we want to be able to measure the volume, because that makes things more concise, more easy to see whether or not there actually is a change. Experimental group. Please read for me the definition of experimental group. Leo was somewhere right there, wasn't he? Leo? No, like in that empty table. Not there. There's no desks over there. I meant like this table right here. I'm pretty sure it was one of those two. Yeah? Okay. That's what I thought. Just you, I can see them, but you can't see them. Okay. Jocelyn. Experimental group. So when you think of a typical experiment, so lab rats in a maze, right? So the lab rats are the experimental group. That's what we're testing on. So we're running them through the maze, or we're giving them the drug to see if it works. So whatever you're applying that independent variable to, that's the experimental group. Control group. Control group. Tiffany. So, typical experiment, you got the lab rats. This one I'm going to inject with this drug that cures cancer. This one I'm not. So they both have cancer. I want to see if the drug works. This is my experimental group because I'm experimenting on them. I'm giving them the independent variable. This one has cancer as part of the experiment, but it's the control group. It's what I use for comparison. So let's say I have these two rats and they get cancer cured. It's a miracle. Is it the drug that I was injecting? This one in the control group was cured too. It didn't have cancer anymore, so probably not the drug. There's probably something else there that's affecting that. So that helps us see if our independent variable is actually having an effect. Okay, so yes, I see you people all getting all excited about highlighters, and that's fine. That's great, so long as you're putting a different color on each one. Put a different color on each one, and there's going to be a reason why. Grab your highlighters, highlight them all a different color. Once you've got them all highlighted, you need to come back here. You need one expo marker, one little pack of papers, one glue stick, and one Post-it note. So come back and grab one of each. One expo, one little clipped deal of papers, one glue stick, one Post-it note. Okay, so you're going to need some spot on the table in front of you. So kind of scoot your stuff aside. This is an expo marker, so it comes off. We're good with it. You're going to create, well, that's not good. You're going to create a data table. Better check to see if your expo marker works. All right, so you're going to create a data table on your table, and it needs, hang on before you do. Hold on. It needs to be a little bit bigger. We need to have a little bit of room, because what we're going to do with it is we're going to take the little slips of paper, and we're going to place them where we think that they belong. So eventually you're going to have a data table. Not yet. Hang on just a second. Give me just a minute. And for our data table, we're going to divide it into 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This one has an H. What do you think that stands for? Okay, so you're going to, not yet, hold, listening to my song and dance. You're going to go through those little slips, and you're going to see which one you think is a hypothesis, and you're going to place it there. I'll tell you right now, for hypothesis, there's only going to be one. Next, if I put CV, what does that mean? Control variable. There could be multiple in control variable, because remember we said we want to control as many variables as possible. Next, IV, what does that stand for? Independent variable. How many slips are there going to be sitting? How many slips will there be for independent variable? How many things do we want to purposely change? One. We want to purposely change one thing. Next is going to be dependent variable. Oops. Oh, I gave it away. How many dependent variables do you think we're going to have? If I poke the bear, probably one. There are some times where there can be more than one, but for this situation, we're probably going to have one slip. And then we have EG, what does that stand for? Probably one slip there. CG, what does that stand for? Control group, probably one slip there. So now you can go ahead and set up your data table, put your slips where you think they're going to go, and spiral notebook. Yes. Do it right on the table. Good. we finished up the safety guidelines. I'll give those to you in just a minute. This, tape into this side right here. Go ahead and do that. Take a look at your definitions. Decide where you think things go. A little bit of background information may be helpful. So you've made some preliminary guesses, and that's fine. Take your Post-it note. And this is our background information. A scientist wants to test different types of sugar solutions to see which will attract more butterflies. A scientist wants to test different types of sugar solutions to see which will attract more butterflies. So now go back and look at the slips that you've placed after you finish writing that down. Does that change anything for you? Does that help you decide, or does it confirm what you have? Whatever you put for your hypothesis, does that now go along with that background information? For your independent variable, the one thing you're purposely changing, does that sound like it goes along with your background information? You can switch things. You're not held to anything. You can keep them the same if you think that it confirms it. If you're not sure, then you're going to go with what you got. I'm going to give you just about 1 minute to kind of look over and double check and see if that changes anything for you. All right, so let's take a look at our slips now. Hypothesis is first. Hypothesis, testable idea or explanation. So looking at the slips, which one looked to you like it was an explanation of what's going to be happening, and it's something that we can test? Go ahead. Say that one more time. Okay? All right. So if I look at that one, there's one word in there that tells me that this has to be a prediction about what's going to happen. What's the word? Will. It hasn't happened yet. So anytime that you see that, you know that that's going to be something that we thinking is happening in the future. So how many slips did we say we should have for hypothesis? Okay, there should be only one slip. Is this something we can test? Can we test to see what butterflies will prefer? We have to watch the word prefer, like butterflies will like. How do you know that they like them? Did they tell you that they like them? I mean, so prefer, we can kind of use that to see where there's going to be more butterflies. But we have to watch words that are biased words like they like or they love it or something like that because we don't know what a butterfly likes and we can't find that out. But we can see which ones they prefer to go to feed at. There will be more butterflies feeding at such and such sugar solution. Okay, so now take a look at what you highlighted. Highlight this slip the same color as you highlighted hypothesis. So I highlighted hypothesis yellow. I'm highlighting butterflies will prefer the sugar solution yellow. Whatever you highlighted hypothesis, that's what you're going to highlight that little slip. Okay, I'm going to skip control variable for just a minute. We're going to do independent variable. How many slips should we have in an independent variable? Okay. I see a lot of people with 2, and I think you're probably trying to hedge your bets. Well, it could be this one or it could be that one. We're not going to be wishy-washy. This is our independent variable. So in this situation, what is the one thing that we are purposely changing in this experiment? Okay, so we are going to purposely change what kind of solution we offer to see if they like the sugar solution. So swap them out if you had more than one there. Whatever color you highlighted independent variable on the sheet, highlight this slip. All right, dependent variable. What we're looking for an effect in, what's the thing that we are going to measure or we're looking for an effect in this experiment? Because I'm changing the type of solution, I'm looking for what? How many butterflies are going to be at each one of those bowls? That's my dependent variable. Highlight that the same color you highlighted dependent variable. Experimental group. What am I experimenting on? Heck yeah. All right, controlled variables. These are things that I would want to keep the same because if I change this variable, it might affect the experiment. If I have one bowl that's white and one bowl that's red and more butterflies go to the red bowl, is it because of the solution or is it because of the color of the bowls? I don't know. Could be the color of the bowl, so we want to keep that the same. If I set some of the bowls in the woods where there's lots of flowers and I set another bowl out there in the middle of the parking lot, is that fair? Is that going to affect something? Could. We don't know. But I want to control it just in case. Do I want to collect ladybugs, or, well, ants? Do I want to collect ants on this bowl and butterflies at this other bowl? Do we want to collect different kinds of insects? So I've got 17 billion ants and 3 butterflies. Is that fair? There's tons of ants in the sugar solution, and I just got 3 butterflies, but you tend to have fewer butterflies. So that's not fair. We want to keep what we count the same. If I've got one bowl that has a gallon of solution and one bowl that has a drop, is that fair? We want to keep the volume of the solution the same. If I leave the sugar solution out all day long and I leave a water solution out for 1 hour, is that fair? We've got to leave them out the same amount of time. Do we have a control group for this experiment? No, and that's okay. Because in order to have a control group, that means that we don't apply an independent variable to it. Can we have no solution? I mean, we can't have that. So we don't have a control group, and that's okay. So highlight the rest of your slips for your controlled variables. Oh, that was loud. Okay. Then on the right-hand side, you're going to use your little glue stick. Glue all of those in whatever order your OCD requires. I like all of my stuff together the same. Your Post-it note with your background information goes there as well. We don't have any of this stuff, so just ignore that. Glue in your slips. Add your Post-it note with your information, background information. show that slip of paper on it. Get violent with everything. All right, the early bus is going to ring here, or bell for early bus is going to ring here in just a minute. Just a reminder, confirmation sheet due on Thursday. You sign it, your parent or guardian signs it, turn it in, and then I'll sign it. And then lab safety stuff is not tomorrow, but the following Wednesday. Study your GHS symbols, the other safety symbols. Your lab safety contract has good safety guidelines on it. Go over that, and the 6 safety guidelines that we wrote in.